Today's lesson is going to cover surface area again, just like last lesson did, but this time we're going to talk about pyramids and cones. So keep in mind the last lesson was about prisms and cylinders, so we were talking about two-based figures. Today we're going to talk about pyramids and cones, which are one-based figures, and then they come to a point at the top of the figure. Notice you've got two different pictures here of a pyramid, and in each one of them, a different height is labeled. So in the first picture, you've got a height that drills straight down through the center of the pyramid. And then in the second picture, you have a height that is labeled on the outside of the picture, which is called the slant height. Each height is going to be used to find a different piece or a different quantity about the pyramid. When we talk about the height that goes straight down through the center of the pyramid, that's actually not going to be used for us until we start talking about volume. So what we're going to use today to find surface area is the slant height. So we're looking for the height on the outside of the pyramid that's at a slanted angle. So when we come down, slant height is very easily found. We're just going to have to use Pythagorean theorem to find it. So a lot of times you'll be given the height straight down through the middle of the pyramid or the cone. We have to find the slant height, which is on the outside of the pyramid, and we can connect the two, and what we've made here is a little right triangle. So figuring out the slant height, if we don't have it, is not really that difficult. We just have to know that we need to find it. So same thing can be true about a cone as a pyramid. Height is going to be straight down through the center of the cone. Slant height is going to be along the outside edge of the cone. If we have one and not the other, we can always connect them into a right triangle and use Pythagorean theorem to find the one that we need. So again, slant height used for surface area, which is what we're talking about in this video. Height of the cone through the middle of the cone will be used for volume, which will be sometime next week. So here's your formula for the surface area of a cone and for a pyramid. We are going to use this formula right here. Surface area equals base plus 1/2 PL. So base is area of the base. So notice it's not 2b this time, because in a pyramid and a cone we only have one base. That's why it's just b. P still stands for the perimeter of the base. And then the L in the formula stands for the slant height, not the height down the middle of the pyramid or the cone, but the slanted height on the outside of the pyramid or cone. So in my first two problems, notice that we are given the perpendicular height, so right down through the middle of the pyramid. And what we're going to do is find the slant height, which is this length on the outside of the pyramid. So we're going to connect the two together, forming a little right triangle. So notice I'm told that the perpendicular height down the center is 100. I'm told that all the way across the pyramid is 200, which means that this bottom piece is also 100 because it's halfway across the bottom. My job is to figure out the slanted piece, which I'm going to call L, and we're going to find it by just doing Pythagorean theorem. So in that triangle I have outlined in blue, my legs are both 100. So 100 squared plus 100 squared, and that's going to equal L squared. So if I do the math for that, we're going to get 20,000. So L squared equals 20,000. And then if I want to find what L is, I've got to take the square root, and I end up with 141.4. So in my formula for the slant height, I would plug in 141.4 if I was trying to find the surface area of this pyramid. In the next one, we're given a cone. And again, notice that we're given the perpendicular height down the center. I'm also told the radius of the cone. And then the slanted piece on the outside, it would be the L that I'm looking for. So finding the L is very easy. It's just Pythagorean theorem. 3 squared plus 4 squared equals L squared. I would imagine most of you probably would recognize this as a 3, 4, 5 triangle. So if you recognize that right away, you can just write down that it's 5. If you don't recognize it, that's fine. If you add up 3 squared and 4 squared, you'd get 25. And then taking the square root of both sides, that's where the L equals 5 comes from. So if I was finding the surface area of this cone, I'd be using 5 for the L in the formula. Moving down, we get into our first couple of problems where we have to find the surface area. So the surface area of a pyramid is going to require that I know the B, the P, and the L. So if I want to find the big B, that's the area of the base. The base is a square 7 by 7, so easily found by just multiplying 7 times 7. You get 49. The perimeter of the base, it's got 4 sides. They're all 7. So 4 times 7 gives me a perimeter of the base of 28. And conveniently in this problem, the slant height is given to me. I don't have to find it. It's the slanted piece on the outside, which is 9. And so I've identified all of the parts of the formula, so just have to plug the numbers in the formula. B plus 1/2 PL. I can tell you right now, one of the biggest mistakes with surface area of a pyramid or cone is students will forget the 1/2 in front of the PL. So make sure that you write down the formula correctly every time you do a problem. So the big B we got is 49 plus 1/2 times 28 times a slant height of 9. Plugging that all in my calculator. I get a surface area of 175. And this would be in inches squared because we're finding an area still. In the next problem, we're going to identify the same 3 things. We've got to identify the big B, the P, and the L. So if you notice the B, it's a square-based pyramid again. So 6 times 6 is going to give me a big B of 36. It's got 4 sides along the base, and they're all 6. So 4 times 6 is going to give me 24 as the perimeter. Finding the slant height. Notice they give me the perpendicular height this time. I'm supposed to find the slanted one on the outside, so I'm going to connect the two to make a right triangle. And what we're going to do is use Pythagorean theorem. So the perpendicular side is 4. They told me that. The bottom side is halfway across the base. So all the way across is 6. Halfway would be 3. And then I'm supposed to find the slant height using Pythagorean theorem. So 3 squared plus 4 squared equals L squared. Again, this is just like the cone directly above. It's a 3, 4, 5 triangle, so my slant height here is going to be 5. Once I've identified all of those pieces, all I have to do is plug them into the formula correctly. B plus 1/2 PL So, got a little multiplication to do, and I'm going to end up with a surface area of 96, and it would be in feet squared because we're talking about an area. On the back of your sheet, we get into cones. Cones are going to require the exact same things. We have to find big B, P, and L. Notice in this problem, they tell me the slant height along the outside. It's 8, so I don't have to find it this time. The big B, it's a circular base, but they tell me all the way across the base is 8, which means that the radius of that circular base is 4. So when I do the area formula for a circle, pi r squared, all I have to do is pi times 4 squared. And that's going to give me an area of 50.3. To do the perimeter, you do 2 pi r, so 2 pi times 4. Doing that's going to give me a perimeter of 25.1. And we already identified that the slant height was that slanted piece, 8 on the outside. So plugging everything into my formula, B plus 1/2 PL, we are going to say 50.3 plus 1/2 25.1 times 4. Once everything's plugged in, it's all calculator. And I get a total surface area of 150.7. My units up there were in feet, so this has to be in feet squared. The last cone on the picture, notice that you're given the perpendicular height, you're given the radius, you're not told the slant, so we're going to have to use Pythagorean theorem. So in order to figure out L, we're going to do 5 squared plus 12 squared equals L squared. 5 and 12 squared together is 169. And if I take the square root, I get L as 13. If you noticed that that was a Pythagorean triple to begin with, a 5, 12, 13, you're more than welcome to identify that right away, and you don't have to do Pythagorean theorem because you just recognize what that third length is. Big B and P require a little work. It's a circular base, so we're going to do pi r squared in order to figure out what the area of the base is. So doing pi r squared gives us 452.4. To find the perimeter of the base, it's a circular base, so you have to do 2 pi r. My perimeter of my base, my circumference, gives me 75.4. And once I've identified all of those pieces, we just have to plug them in the formula. So again, make sure you're writing down the formula correctly. And then just plug the numbers in. 452 was my big B, 75.4 was my P, and 13 was my L. So we plug that all in my calculator. Make sure that you type it correctly. You type it wrong, the calculator is going to give you the wrong answer. And I end up with 942.5. My units above were in feet, which means that my surface area would be in feet squared. Moving down, the last thing we're going to talk about is how to find the surface area of a sphere. So a sphere is like a ball. It has a really easy formula. Once you recognize that you have a sphere, all you need to know is what's the radius of the sphere. So what's the length from the very center of the ball to the edge of the ball. So once I know that, the formula is just 4 times pi times r squared. So very, very easy formula. You plug the numbers in, you use the calculator, and you give an answer. So the problem says find the surface area. So we've got 2 balls here. It says when the radius doubles, does the surface area double? So if I go from a ball of 3 centimeter radius to 6 centimeter radius, does the surface area double? Does it just get twice as large? So we're going to answer that question. So I know that the radius of the ball is 3 here. So it's as easy as just plugging 3 in for the radius in the formula. So 4 pi times 3 squared is going to give me a surface area of 113.1. And we would be in centimeters squared. So what we're going to look at in part 2, part B, is we're going to see is if we double the radius from 3 to 6, does the surface area double? So we're going to plug in a radius of 6 this time. And we're going to see what our calculator says. I get 452.4. So we found both surface areas. Now let's compare. Does doubling the radius double the surface area? The answer to that question is very easily figured out by just dividing the 2 surface areas. 452.4 divide by 113.1, and you get an answer of 4. So the answer is no, it does not double. It actually quadruples the surface area. There is a reason for that, and that's something that we'll talk about at the end of this unit in the very last lesson. It's actually something we've talked a little bit about last semester when we studied similarity. The last two problems down here on the bottom, I'm going to leave for us to talk about in class, next class, because I think that they will make more sense if you're able to ask questions as we go over the problem. So leave the last two. We will talk about those first thing next class. If you have any questions over any of the problems that I did work out in the video, just make note of what they are so that you can ask in class next class.